We'll look at standard free energy change. Delta G is the change in free energy that will occur if the reaction in their standard states are converted to products. Delta G cannot be measured directly. The more negative the delta G value, the further to the right the reaction will proceed in order to achieve equilibrium. Equilibrium is the lowest possible free energy position for the reaction. Several methods to calculate it using delta G is equal to delta H plus T delta or minus T delta S. Or we can use Hess's law. And remember that when we did that, we wrote down the equations, and then if we had to flip something, we flip sign. And so for this reaction, the diamond needs to be on the reactant side, graphite on the product side. So we need to flip that second reaction as I'm drawing in. And so it will also change the sign. And when we write it down and add everything up, we end up with a negative 3 kilojoules for our reaction. The third method of calculating this is to use the standard delta G of formation found on a chart, and it's the sum of the products minus the sum of the reactants is the delta G of the reaction. There is a pressure dependence on free energy because delta S is pressure dependent because it's volume dependent. Larger volume means more randomness, which will also mean that a lower pressure is more randomness. The equilibrium point occurs at the lowest free energy, so when delta G is equal to 0, Q is equal to K. See, from this formula, delta G is equal to delta H minus T delta S, and delta G is also RT, negative RT times the ln of K. So if we manipulate this equation around, we can see that the ln of the equilibrium constant is equal to negative delta H over RT plus delta S over R. And all that I did was put the ln of K by itself. And if we look at this form for the second part where I separated out the 1 over T, that is the slope of a line. Y is equal to mx plus b. So the ln of K is proportional to 1 over T. And we can use this to calculate either the T, the delta S, or the delta H, or the equilibrium constant when we have this.